Good morning or afternoon, whenever you're watching this. We are on page 18, kind of a short read today. We checked our homework. We played with some Hot Wheel cars to figure out how to get the speed using that formula. Speed equals distance over time. So it's pretty simple. You guys can figure that one out. You do need to remember that one though, because you will see it again. Okay? All right, let's talk on page 18, okay? This is actually talking about plate tectonics, okay? I usually cover this in marine biology, and we will hit on it again because this one doesn't go into as much depth as we're going to in the marine biology portion of it, but it hits upon it and kind of explains because, again, this is talking about calculating speed and motion is what it's doing. That's not actually a lesson on plate tectonics. Yes, ma'am?
Are you going to take
I am going to take that up. Remind me at the end of class and I will come by and take that up as I'm handing out the others. Thank you. Okay? So it starts off with, have you ever noticed that Earth land masses resemble pieces of a giant jigsaw puzzle? And we've talked about that in class. Some of you actually mentioned that. And it's true. The east coast of South America, for example, would fit nicely into the west coast of Africa. The Arabian Peninsula would fit fairly well with the northeastern coast of Africa. And since the 1600s, people have wondered why the Earth's land masses looked as if they would fit together nicely. Okay? So, because, yeah, and they now decided over time, scientists has discovered that we are actually sitting on plates that are moving a little bit every year. Okay? So the Earth's rocky outer layer consists of pieces that fits together like a jigsaw puzzle. This outer layer is made of more than a dozen major pieces that are called plates. The boundaries between the plates are cracks in the Earth's outer layer. And you can see that there in the picture up there on the top of page 19. Okay? And the boundaries do not always lie along the edge of the continent. Okay? The eastern boundary of North America's plate, for example, lies out under the Atlantic Ocean. Okay? Many plates have both continents and oceans on them. The one on the west coast of the United States, if you would notice, it cuts right down on North America. It comes right down the outer portion of the continent. Okay, that is why that area is very susceptible to earthquakes and things because you do have that major plate there, the edge of it. Okay. Yes.
Could the Garden of Eden then, when the entire world was together and like everything was in like a spot, and then the garden was like now guarded, and then they went to
Well, they're estimating it was like 225 million years ago. So, but since time doesn't, he wanted to know about the Garden of Eden. Could it have existed during the time all the land masses was kind of together?
separated them as
I mean, I guess technically it could because, we don't truly know how long everything's been going on. I mean, we talked about New Earth, Old Earth theories before. And time doesn't actually exist for God. I mean, time exists for man. So I don't know, Spears. I can't answer that and give you a definite yes or a definite no on that. It's purely possible.
Like in the Bible, it says that every kind of it says that every kind of animal was in the garden.
Yeah.
And those animals would have had to live.
Well, but yeah.
Like in their habitat.
But you also got to think about as it spread. So yeah. So I don't know. You back again? I don't know. Yes, Caleb.
Okay, so two things. So North America is the largest plate, is that correct?
It is it's one of the largest plates, yes.
And then the second thing isn't where like those cracks and that, aren't they called like fault lines?
Yes.
And like it's way high chance of getting an earthquake if you go on those.
Yeah,
fault
yeah, if
lines?
you're closer to a fault line, there's a better chance of being near an earthquake happening, yes. That's why California is pretty much waiting for the big one to happen at any given time, okay? All right. Now, the theory of plate tectonics, scientists use the concept of plates to explain how land masses have changed over time. The theory of plate tectonics states that Earth plates move slowly in various directions. Some plates slowly pull away from each other. Some plates actually push against each other or towards each other. And some plates just slide past each other. And when we get to marine biology, we'll talk about the three different types there that they're talking about, because they all have a name to them.
Don't plates shifting cause tsunamis? Yeah.
An earthquake way out in the ocean can cause a tsunami, yes. Okay. According to the theory of plate tectonics, Earth's land masses have changed position over time because they were part of the plates that are slowly moving. Okay? So why do they move? Because of heat, okay? This uses an example. If you heat a pot of water, it starts to warm up down on the bottom, and then it starts to come to the top. When it comes to the top, it starts to cool again, okay? And more water is taking its place, and that's why the entire pot eventually gets really hot and starts to boil, okay? And the thing about the inside of the Earth, under our crust, remember we talked about how our core is hotter than the surface of the sun. So it's pretty warm down there, okay? And we know right down below us is all the molten rocks and all that stuff, okay? So we know that all that's going on. So the heat is what's causing things to move like that, okay? As more heated material rises, it pushes aside cooler material at the top of the layer, and eventually the cooler material sinks downward, and the rising and sinking of all that is a slow moving current beneath the Earth's outer layer, and that is what causes the plates to actually move. Okay? And you see right here on page 20, it kind of it shows you what they estimate it looked like 220 million years ago, 180 to 200 million years ago, 135 million years ago, and then present day. Okay? And unless you have experienced an earthquake, you have probably never felt the earth plates move. Okay? And why not? After all, you live on one of the earth's plates. One reason may be that they move so slowly. Okay? Some plates move at a rate of several centimeters each year. Others move only a few milliliters. Okay, and a centimeter, if you remember, there's 100 of those in a meter, and a milliliter is 1,000 of those in a meter. Okay, so we're not talking leaps and bounds here. We're talking kind of a slow movement here. Okay, knowing the average speed of Earth's plates allows scientists to explain how Earth's surface has changed over time. It also helps them predict the future changes. And this, again, it shows you how they think it looked in the past, okay? Suppose you study the motion of a plate. You find that the plate moved a distance of 5 centimeters in 1 year. So the speed of the plate is 5 centimeters per year, obviously. You can use this speed to predict how far the plate would move in 1,000 years, okay? So you start by rearranging the speed formula to find distance, and then calculate time. And to find distance, it is speed times time. Okay? So if you had 5 centimeters for 1 year times 1,000 years, obviously that would make 5,000 centimeters over a 1,000-year period of time. Okay? So we're not talking leaps and bounds again. It's not, you're not going to, in your lifetime, you're not going to be opening up your door and walk over into Europe, I'm afraid it's not going to close the gap quite that quickly.
Well, maybe.
Okay? It's not going to close the gap that quickly. It can't. It's not going to.
I know,
It
not,
can't.
not
No.
in our
No.
lifetime.
That's what I just said.
I know,
I said in your lifetime. I said in your life. You've got to just start jumping ahead. Yeah, but in 40 billion years, yes, in 40 billion years, you can probably walk through Europe.
But yeah, but then
And if you're still here,
I'll be dead.
I will shake your hand when you get there.
But you'll be dead.
I will take your
And you won't be in 40 billion years. Okay.
Wow.
See the conversations we get to have in sixth grade sometimes? Isn't that exciting? Okay. You can't tell me you don't miss this. You're sitting at home able to study and think without interruptions. You can't tell me you don't miss this. Come on. All right, we're going to watch the video now. I will give you the link. Hope you enjoyed it. Bye.